Hi, welcome to part two of building our modular system. Today we're going to work on two different things. We're going to work on our riser modules, incorporating risers into modules, and we're going to work on our corner systems. We have two different versions of those. Last time we showed you the tools and methods as well as materials that we were using to create our module sets, and we showed you a few things about how to create the corner blocks, to find our joinery and different joinery methodologies, and we're going to use those here. Today, however, we're going to focus more on how to generate our risers and how to generate our angles for risers and techniques that we use to get those measured out as well as in place. We're also going to be talking today about these corners, and in this case our corners for generating these corner blocks and how to create those. So all in all, this is a fun project, so let's get started. Let me show you how I built the riser module. Okay, I brought out my module we're going to be working with, and you're going to notice a couple of things. It's very similar to what we saw with the flat 4-inch module that we used in the last video. The only difference is now I'm dealing with different heights. Okay, this is literally a 6-inch module and this is an 8-inch module, and I refer to that in the height size. I've cut my blocks and I've cut my cross pieces and front pieces to 8-inch, so that's basically made a box. I also have, as you can see over the top, get this up here really quick, is I have the two pieces in the center like we did before, so that if I wanted to add a leg here, I can do that. Now, what we're going to be doing here is we're going to be doing a number of things from this particular system. First of all, this is going to be connected on this side to a 4-inch module, so I'm going to have to wind up cutting that. However, if you remember the last program, we talked about making a higher backdrop, and that's what we're going to be doing here. But in order to make the whole thing work in this context, I made everything the same size so that I can show you how to do it from scratch. The front will start at 4 inches and pretty much stay that same length across the front. However, on the sides will actually be lifted across, and of course in the back it'll actually go back down. Now, with that being said, you're going to see a number of things that are a little bit different here than you saw on the first one. First of all, it's the height. The joinery is a little bit different because I've already put in the joinery to make the boxes symmetrical. And that's going to change, and I expect it to change. But for right now, I just wanted to put it together. We're going to show you how to actually do our layouts specifically for risers. Now, there's two ways to make a riser, okay? The first one is an integrated, where I'm actually cutting the riser into the ribs or the cross members here. And we're going to show you how to do that. The second way is actually done with another piece, where you actually take a separate piece and you actually stack it on top, whether that's from a tabletop. For example, if I were to put it on a tabletop, let's go this way, and I create my rise out of that, I'm not really too in tune with that. I don't like making a full tabletop and doing the rise out of that. If you're going to do that, there are foam inserts that you can put on top of the tabletop, and that works just fine. But if you're going to be doing it with the framework, we're going to show you how to do it an easier way. Sometimes it's done on the side and done with screws, and in other cases it's done this way, where it's actually made with two pieces. It's very strong, but you have to deal with the angle, and that's something we'll show you how to deal with later. All in all, when you start making risers, you have to start out with a plan. And the first thing that we need to deal with is what we call the elevation. The elevation goes from where it starts to where it stops. And the elevation that I'm worried about is not the module itself, it's the track. We'll show you how to do that next. Okay, let's talk elevation and angles for just a second. Now, everybody's heard the term 1%, 2%, 3%, whatever it happens to be. It doesn't matter what it is. The angle of the rise is going to be determined by two things. First of all, the end point, and then obviously the exit point. So the end point of where the rise starts and the exit point of where it ends. Now, obviously where it ends is going to be lateral, meaning that it will be in plane, so to speak. The big thing we need to worry about is this piece right here, and I'll just show this to you for illustration. Let's say this was the rise. Now, this angle is determined based on the length and the rise of this thing, 1%, 2%. Everybody knows how to find that information. There's a lot of good information on the internet how to do this. But this angle right here is what we need to deal with. So, if the angle is pretty narrow, it makes life a little bit easier as far as the ability to make the rise out of it. But what we want to do is we want to make this in a transition to where it's not a perfect, let's say 2 degree or 2% grade. You can't go from 0 to 2%. It doesn't work like that. We need to find a way to actually transition that. And let me show you what I mean. Let's say these two pieces were rail cars, and on the flat, they seem to work out with no problem. However, when they get to this here, you'll see that the rail cars from this particular section are going to have a problem. Is that if the transition is too strong, obviously the couplers come apart and maybe the car doesn't work. So we need to figure out a way to make sure that this transition is a little bit more subtle. So in this case, instead of doing a perfect 2% angle, we might go with a 1/2 degree, then another 1/2 degree a little bit further, and a 1/2 degree a little bit further. And we'll show you how to do that. But right now, let's deal with how we deal with our transitions. And we're going to lay that out a little bit differently. So to start with, we need to know where our transitions start and our transition ends. In the architectural world, this is called elevation, and that's what we're going to deal with. Now, to start with that, we need to know where this is going to start. Remember, I told you that this actually starts on a 4-inch module, and we're going to start there. Okay, so let's go ahead and calculate how we get our elevation. That's the first thing we need to deal with because we have a good idea where our track plane is going to be. We're not going to deal with that just yet because we don't know where those pieces are going to be. Okay, so we're going to deal with our elevations. As I told you, this end of the module is going to be on a 4-inch section, so I have to start there. So this particular side is going to have to line up to our next module. So in this case, it's going to be 4. So I've actually drew a line and I've marked it 4 inches. You can see this particular module is a 6-inch module height, or should I say this 6-inch block. Now I've created a 4-inch from the bottom because that's where we're going to start. That's our reference point. And I'm going to strike a line. Now that line, theoretically, because the two main lines are going to be at 4 inches all the way across, I would just strike it and keep that line going all the way to the end. But where I'm going to start my height is not at the end. You never want to put it at the end. The reason being is because if you put it at the end, you're going to have to account for that angle immediately. The second thing is that it doesn't secure too well. So literally you should always have it inside, maybe 1 inch or 2, wherever it happens to be. So I've calculated mine to be 2 1/4 in from the end. Okay, so I go in here, mark 2 1/4. That's my first point right here. Okay, can't see that just yet, but essentially that's my first point. That's my straight line until I start the rise. Now, the next thing I'm going to do is I'm going to go on to the other side and I'm going to identify the height on the other end. Now on this end it's a little bit different, okay? I've already identified my height on one end and now I need to identify the height on the other. The height on the other end is actually going to be 5 1/4 inches. So I'm going to go to 5 1/4 and make a mark. I'm also going to make a mark at 4. The reason being is because my main line is at 4, so I'm going to make a mark at both spots. Now this is where it gets a little fun. Get yourself a straight edge 48 inches. They sell these at, literally any place on the planet. A good straight edge works not only for laying track, but also for what we're doing here. We need to actually line the two pieces together, both the 4-inch as well as the 5 1/4. And I'm going to do that next, and I'll show you the easiest way to do that. Okay, I've set the modules up on their side in their orientation. Now, I've also have the marks on each end that I need to do, and I put a clamp on here temporarily just to make sure nothing comes out of alignment. Now, I take my long rule And literally what I'm going to do is strike a line between the 2 points. So the first point here on this side, and the second point on the other side. And now I have my elevation on both ends. Now I have my elevation on both ends. And this is going to be determined how I transfer those lines onto our cross member so I know what angle I need to sand them down to. Now, we were talking about this angle here. This angle, when calculated, is 2.6 from end to end. And that's fine for what we're trying to do. Now, first thing I need to do is figure out where I need to make and transfer this line onto the rib. To do that, I need to know where my track is going to be, in this case my sub road bed. So if I were to take, I'll just use this as an example, my long pieces, and I would do them all the way across, I would say, for example, I have one here, I have one here, and I have one here, maybe with a little bit of a curve into it, just because we're going up here, and that's fine. The only thing you need to do is mark the top of where those are going to be, and then we can actually transfer the lines from there. And that's kind of what we're going to go through next. Okay, so we're ready to start cutting our ribs. So we have two different lengths of ribs that we need to do. We have 3/4 and we have 1/2 inch. We're going to do the 3/4 one first. And we're going to cut that here on the table saw. But before we use any power tools, let's talk about shop safety. Be sure to read, understand, and follow all the safety rules that come with your power tools. Knowing how to use your power tools properly will greatly reduce the risk of personal injury. And remember this, there's no important safety rule than to wear these safety glasses. Also, when wearing long sleeve shirts, make sure your sleeves are actually rolled up because they could actually get caught in the blade or on the side, causing severe damage. So what we're going to do is we're going to go ahead and cut this at the desired length for the cross cuts. We'll deal with the height later. Rib we need to make is actually the one that sits down at the 4-inch level. We know it's going to be 4 inches tall, so we can make it at that height right now because we're going to be cutting off the other one later. So I'll set my saw to 4 inches, which is accurately tuned, and we'll make that cut. Okay, I'm going to stop here and show you what we've done so far. We have our boxes complete. We have our transfers complete. Now we need to figure out where we're going to put our ribs. We know one is actually going to go right here, so we're going to install that now. We're not going to glue it in or a pocket screw it yet. We're just going to put it in its proper position. I have another 3/4 inch piece, and I have 2 1/2 inch pieces. We really don't need 3/4 inch everywhere, so you can actually do it with either one. But I'm going to put in 2 ribs, a 3/4 inch piece here, a 1/2 inch piece approximately right here, and then another 1/2 inch piece approximately right here. Now you may think this is a lot of material, but don't forget we're going to be cutting out a lot of it. So we're going to be cutting along the front, we're going to be cutting along the side, we're going to be cutting along here. Now, the reason that I'm putting the extra ribs, obviously, is not only strength for the track, but I want to make sure that the risers have enough support all the way along. It doesn't matter where the ribs actually go, we just need to make sure that it's done properly. We'll use pocket screws to put the ribs in, and then we'll start going through the process of transferring those lines. So we can either put the pocket screws in now, or we can do it later. It's completely up to you. We don't necessarily need to do it now because I can transfer those lines and start cutting and creating my profiles before I glue everything up. And that's probably what we're going to do. So for right now, we have a good start of where we need to go. Now let's transfer the lines for our track plans along the top, and then we'll start transferring these lines from where they sit within on the rib, on both the front and the back. Make sure you label these. So if this side goes to this side and this side to this side, make sure that's labeled correctly. You need to put a mark on the outside or wherever the case may be. Finish out your track plane, and then once you have that part done, we can start to think about profiles. We'll talk about that later on in the segment. Okay, now I've identified where I want the ribs to actually go. What I've done is I've actually measured out where they actually need to be, and I've made a mark on each end. So I made a mark on the front and the back of it. Now in this case the orientation is correct. So I made pencil marks on both the front and the back of the plywood on each end. This is going to help me determine my angle when I go to sand down the angle. That's not a problem. It should be a given at that point. Now what I need to do is I need to mark out the track plan where it actually needs on the ribs as well, because that also plays a part. So if, for example, if I'm in a culvert where it comes up, I still need to be at the right height, whether it comes up or stays down, it doesn't matter what it is. So in this case, what I need to do is I go ahead for each rib, identify the track, and identify the in and the out on each end. We'll kind of go from there next. So what I'll do is I'll start at this end, and since this has a slight bend, I know where the bend is at, and I'll actually create that as I go along. So that's what we'll do next, and then we'll get to measuring the front. Okay, so what we're going to do next is we're going to start the process of identifying and measuring out where the cuts need to be to equal the appropriate angle. So we know that the first two are going to be at the 4-inch, but this one starts an angle. So the first one that we're going to identify is we'll start the first two. I know those to be at a given height of 4 inches. So worst case scenario, I'll just measure out, make sure I'm at 4 inches, come out to the 4-inch mark, align it, and then strike a line. Okay? I'll do the same thing, so next thing I'll do is I'll mark, actually it's probably easier to take that off. So what I'll do is I'll mark the next one, which the front end is going to be, if I line this up properly, so from the leading edge to the first cut line is 4 1/4 inches. So that's what I'm going to measure down at. Mark 4 1/4. Exactly. 4 1/4 on the other side. And when you have a flat table saw and everything is flat, it makes this job go a lot quicker. Okay? Now, the second line I need to do is on the back. So I measure from here, and now that line has gone up 4 and a little over 1/4 inch. So I go to the back side, measure down from the back end, align it, find my 4 1/4. It's easier with my glasses that are off. Actually, I can do it this way because the alignment's perfect. So it's going to be... Okay, I'm going to bring this closer to the camera to give you an idea of what the piece is. So this is our outside of the module here. Here's our 4-inch line. There's 2 tracks, one here, and here's our elevated, our first elevation. You can see that this literally is up a little bit. It's not much, but it's a little bit. Now what I needed to figure out is once that part is done, if there is a profile, whether that profile goes up or that profile goes down. Okay? Doesn't matter what it is. In this case, we know that our front edge of the module sits at 4 inches. Doesn't have to be, but it sits at 4 inches. So literally this is going to come this way. But our profile up is actually going to start here and then work its way up, let's say to this mark. Okay? That's literally what we need to do. Now all we need to do is cut all these pieces out to the line and just copy the process all the way through. So this is our last rib in line there from the module to the back. I've actually outlined the bottom of the road bed, and here's the bottom of the road bed on the other side. You can see it's a little wider because there's a small curve that goes there, and the mountain will actually come down to this side. all I need to do is actually cut this out. But what I want to do is I want to ensure that this line is level. Now, with the module this way, the lines on the back, I've also drawn them on the black. On the back, this line will actually be taller than this line. So what I mean by that, on the back side of this, it'll actually be higher. So that's how I determine my angle. When I get this in place, what I'm going to do is I'm going to take a rasp and I'm going to angle from line to line, which will give me my angle. All I need to do is follow that all the way through. It's a situation every modeler seems to run into when dealing with risers. First and foremost, this is a typical framework that many modelers can use, whether it's modular or permanent, doesn't matter. You have a step down. How do I get risers above the track line to work across from end to end? Let's say we're just going to go here of a given height. Doesn't matter what it is, but for right now we need to have our risers be actually on top of the framework rather than underneath it. We'll just put this like this. Now, I can still use the same line that I used before. The difference is how I measure that information. Now, let me show you what we mean here. We're still going to use our rule to measure this distance out, except we're going to do something a little bit differently. Bring out our rule. So it's a little bit easier. First thing we need to do is move it to the front. The same thing holds true here. Doesn't matter where it is. Now, our lines are still listed as far as our elevations are concerned. Now what we're going to do is we're going to say, okay, if this first line is at 4 inches and I want to start, say, at the 8-inch mark, that's where I put my line. Mark it at the 8 inches. Move on to this one. Identify the number. Now, if the first one was at 8 inches, okay, from, let's say, 4 to 8 is 4-inch gap. All I do is take that 4-inch gap from that line, mark that 4-inch gap here, and continue it on down the line. That way, the elevation will be identical all the way across. Now, it doesn't matter if you have the 3/4 or the 1/2 inch pieces. You still have the same situation there, is where you actually put it on here, identify the height from your line to your first reference line, and then just copy that all the way through. By the time you get down to the end, this line will actually be parallel to the lines on here. All you have to do is cut them at that point. Now, realizing, of course, that this block will actually be longer, theoretically, than this block. Let me superimpose some lines on here to show you what I mean. Mark this really quick. And as you can see, the block lines will be slightly one higher than the other. And that's fine. At the end of the day, when you move all the way down, you can use this technique to do all the way down your railroad if you need to. Just follow the elevation as you see fit. Now, what happens if I go in the reverse? Let's say this is the lower end and this is the upper end. Well, that presents a small problem, but there's an easy way to fix that. First, we put on a stick, okay? Let me show you how to do that next. Okay, here's another situation where modelers have a little bit of an issue. And the first is to actually do an elevation line where I don't have the ability to do an elevation line listed in the front. For whatever reason, how do I judge that angle when this front is not available for you to actually do a measuring against? Well, there's a real simple trick that we know how to do it, is we're going to use a string line. I've nailed an end point in the side, and I've temporarily put up a stick on the other side. And what we're going to do is we're going to use that to identify our elevation. straighten my stick out. We take our string line, and what we're going to do, and we're just going to superimpose this, is I'm going to identify my elevation here. We'll just wrap it around. Now, with that, all I need to do is bring this system all the way up to the front, and make a determination of what my low end to my high end is there. Let's say that's 5 inches. And every riser at that point, I measure from the string line 5 inches up, all the way across. In this case, 5 inches, and so forth. So every time, all I have to do is bring it up to the corner, measure up 5 inches, whatever that is, put it on my track line, put it in place. Literally, that's all that needs to be done. It's a simple way of identifying elevation when you don't have the front to actually draw on. It works really well. Okay, let's talk about how you go about cutting the ribs. So this is the part I need to take out. So if I were to look at this, my roadbed actually sits on this line here and sits on this line here. They're both level. There's no super elevation. There's no angles left or right. It is actually 90 degrees to the bottom. Now, remember, this is the leading edge. This is the back edge. So the back edge is going to be higher than the front edge. A little bit, 1 or 2 degrees. How you cut that is important. So let's talk about cutting options. Well, it's more than likely everybody wants to just get down there and start cutting out whatever pattern they need to. And I would recommend to hold off till you really think about how you want to do this. So let's say my terrain, and I've kind of identified my terrain as being coming down this line. Now, with that being said, I have options. If I wanted to go up here, I obviously just can't cut this straight across. So what I would do is I would take a jigsaw and leave the line. So the line that's listed on the back here, I would actually leave the line because that's my perfect mark. Same thing holds true on the front because the back is higher than the front. If I put it through a table saw, I want to make sure that I cut to that line only. It's perfectly squared. Now, I can't come all the way through here because this line is actually higher. So I would literally start by chopping away little pieces that I don't need until I get to where I'm going to do, and then just cut off what I don't need. Keep that in mind when you go through this. Now, if the terrain actually goes up, the whole thing will have to be done with a jigsaw. So let's talk a little bit about technique first. It's quite likely that everybody wants to go out there and just put their hammer down, put their fingers down, hold it in place. Let me get this out of the way. I have this unplugged, obviously. And then just have a way to go through this and start cutting away. I would recommend against that too. What I would try to do is I try to get a way to clamp this. I want to clamp it on the front and on the back. Okay, the reason being is because I want this as straight a cut as possible with as little tear out as possible. Keep in mind, even though this is an angle, I need to cut at least close to that line. So I'm going to leave that line. So I just want to make sure that I give myself a little bit of ability to fine tune it with a sander. It's very difficult to put material back on. It's not that difficult to take a little bit of material off with sanding. So with a little technique, let's go ahead and do a couple of these. Put my rib onto a side piece here, and I just make sure that my blade won't hit anything underneath. I've marked out where I'm going to cut. Doesn't have to be perfect, but it has to be relatively close. Got a very sharp blade in here. All I'm going to do is follow the pattern along. Now we're ready to sand off whatever we need and get that down to our final destination. As you can see, I still see the line on the front as well as the line on the back. I'm using a wood rasp here, and the wood rasp, there's a variety of them. There's an aggressive cut and there's a pretty fine cut. I'm using the fine cut. This is pretty thin wood. It'll go through relatively easily. And all I'm doing here is going from line to line. I start out at one end, put it on the end. And as you can see, in a pretty quick work, I can get that line all the way to the end. Real easy to do. Just takes a little time and a little effort. Okay, let me show you a little more of a sophisticated way to cover these angles. Now, this is one of my ribs that actually goes into the module, and what I've calculated is this is the front side or the low side, this is the high side. This is the high side that we actually want to cut the line to. I've taken one of these and measured my angle. So I've measured my elevation from that point on. I set it at 90, measured the elevation, and then I matched that actually to my saw blade. Now all I need to do is bring up this. I've then measured that line to the end, and that's where I need to cut. All I need to do is put my table saw to that line, then cut what I need, and I'm good to go. It's a simple way of doing it. So let's take a look and see what it does. I want to show you what we're going to cut next. So this is the back side of our piece. So what we're going to be cutting next is this piece here. I only need to go as far as here because I'll be making a little bit of terrain into that side. So we'll make our first cut this way. Okay, with the first two cuts done, all I decided to do is to bring out my miter gauge and cut off the excess I don't need. Just makes life a little bit easier when I want to cut my terrain later. It also helps give me an indication of where I want to make my terrain. It's a lot easier to do it once you have a good idea where it is than it is try to do it now. Nothing to it. Okay, I'm bringing the camera around to show you what we're at so far. This is all just loosely fitted, but I wanted to show you, kind of give you an indication of where we are. All the ribs have been cut. And as you can see, and I'll go down to a profile here, if you take a look down at the profile, that first profile is actually pretty good. And that's the 4-inch side. If you look over at the elevated side, that profile is actually pretty good as well. There's some minor sanding and minor adjustments to make, but we can make those pretty easily. And we'll do that once we start putting them in place permanently. Now, the next problem that I have is actually out front. I need to cut to this line all the way across. The reason being is because that's the front of my module. The second issue I have is the following. I've cut this side actually down on both ends. Now the joinery don't fit, so I now have to mark for the joinery on this side. I can get away with it by clamping it and putting a pocket screw in here with no issue, but I think I want a little extra power or a little extra strength in this case, because this is going to be an end module. So we'll go ahead and mark those. I not only need to do it here, I also need to do it here, there, out front, and anywhere I don't have a connection. So we'll kind of do that next. Okay, I want to stop right here and show you where we are in the process. So what I've done here is I've actually cut the terrain, or what I expect to be the terrain in its final state, off these ribs as well as along the back. As you can see, it's taller on one end and shorter on the other, which is kind of what we wanted to do in the first place. I have to deal with the blocks. So the blocks are, since the front is now cut at 4 inches, the block is still sitting at 8 inches. This is the piece I actually cut off. So you can see the joinery, which used to sit out here, I now have to make another piece. And that's easy to do. All I have to do is mark it, line it up, and ready to go. Now I have a chance to check out my angle of elevation, and I've actually put my ribs in their approximate location of where they're actually going to be. And it doesn't have to be perfect, just has to be good enough and it's sitting on a flat surface. Here's where this little tool comes in. This is a straight stick. You can use a level, anything with a straight edge. And what I want to do is I want to put my stick across that particular elevation. Now, obviously if the elevation is shorter, use a shorter stick. If it's longer, use a longer stick. What I want to do is just put it across, and what I'm looking for here is to see if there's an angle of rocking. And as you can see, that actually is. The rock is actually this rib here. I have two options to fix that. First, I can actually sand down the rib where it meets here. That's one easy option. Doesn't take very long to do. It's not very much. The other option is I can just move it out a little bit. Since that lowers the angle, I can move it out to where I need to. And now everything touches without issue. I have plenty of support all the way across. It doesn't have to be absolutely perfect, but this is perfect enough for me. Once I put in my sub road bed, that won't go nowhere. The only thing I need to do is I need to follow this all the way down. If I have any high spots or low spots, I need to deal with them directly. Mostly done by sanding. As you can see, my gaps, there's no gap from the end all the way through. Same thing holds true when you move down a little bit longer towards the end. I have a small gap here, but I can fix that by moving the rib over just a little bit. And that problem solves that. From there, it's just a matter of going through the process of putting out my sub road bed and I'm good to go. The last thing I need to do is to sand out where I need to sand. Not a problem. Fix my joinery, cut those down. This will be ready for glue up. Okay, I want to stop here and show you where we are with the progress. I've actually gone ahead and glued in the sides, the middle sections, as well as the front and back. I've shaped them out, and what you saw was me finishing up the last of the smoothing out process. Now I have a terrain. The next thing I want to do before I do anything else is to bring out my track plan. And I've made a couple of the templates for the road bed, and I'm going to place them on there in their approximate locations. A couple of marks, and I've left them long, and that was done on purpose, and I'll show you why here in a little bit. So now that I have these in place and I have the ribs in their approximate location, a couple things I wanted first of all to do here is to see if there's any deflection, and we don't really see a whole heck of a lot, and that's pretty good. But I know you can't see it, but if you take a look at this first rib here, which is the one that is next to the blocks, my connection for my angle actually starts a ½ inch past that rib. So what I need to do is I need to make a relief cut, and I'll show you why that's important here in a few moments. Once all these pieces are in place and everything fits like it's supposed to, I'm then going to gently mark and screw only the permanent ribs on the blocks themselves. I'm going to leave these loose for now. We'll identify once they're in the right location, then I will go ahead and mark them in to where their locations are, and then screw them into the side. So we're actually going to do that next. Okay, I put the module up on its side so I could show you a couple of things. I've actually glued and screwed all the ribs in, and I've actually made these relief cuts using this template you see right here. Just attach it on, trace it out, and it's going to help alleviate some of that weight because each rib actually has that. Let's move this back down on its face. Now, the only thing left to do is to trim off the ends nice and flush, and this module is done. So let's get to work on some corners. So let's talk about corner module for just a second. Before I can lay out any corner, I need to know what my angle is going to be. And most corners are literally at 45 degrees, so we're literally going to use that. Just makes it easier for everybody to identify. The width of the module typically is going to be based on what your end distance is from your modules that are going to connect up to it. So most of the modules are literally 2x4, so we're going to go with 24 inches. That's going to be one of our end points. The angle at which we start off with obviously starts at a 90, but when you get to the inside of the angle, it's literally at 135 degrees. So I've drawn this out on a piece of plywood where all my angles are going to be, and literally this is to scale. So I know that this angle is 135, which means that my cut is a 45 degree angle on my table saw. So what I did is I took another step back and I decided to actually draw full scale of where the pieces need to be. And that created this block, okay? Now, that block and that angle is what we're going to be using. But let me show you some common issues that most modelers have when they create these types of corners. The corner itself literally is a 45 degree corner, and that's okay. Now, there's a couple of ways to go about putting this corner in place. You can actually overlap it this side, which is common. You can overlap it this way, which is common. But one of the issues that we see is the fact that there's no way to easily or tightly connect them together with a mechanical fastener. Typically you see these put together with screws, and maybe some glue, but over time they simply sort of start breaking apart and chipping out. That's really not that fun. So I decided to look at a possible alternative. The other alternative is to cut that angle in half. That angle in half would be 22.5 degrees, making my 45 degree. I have the same problem here. While the angle is good on both ends, this piece had the cross member has to be cut precisely, which is very difficult when you're dealing with angles, as well as you're also going to have to find a way to fasten this together. Screws can work here, but there's very little material once you start driving them in, so that eliminates that issue. You can use glue and actually put in a couple of brad nails, and that'll hold it for at least for a while. Most of the time there's backer blocks put on the end of this, and sometimes that works, sometimes that doesn't. It just depends on how well those are cut. So again, we're going to look at the way that we built our modules. Going back to my pattern, I've done the same thing, except what I did is I've actually extended my block to include the angle that's built into it, and that's what I have here. So our standard block is a 1.5 degree, but the block with the angle in it is 135 degrees. So on my full scale pattern, I've actually can put out, and it actually sits in that 135 degree angle. The only thing I need to do now is define the length of this, and those are all 90-degree cuts. So let me lay this out, and we can move ahead from there and show you what's next. Okay, I've laid out my diamond pattern and all my rails, my blocks, and where they need to be, and I've started working on the joinery. I have two left to do, and those are the inside of this particular side. I've already done the outside to verify where they need to be to make sure everything is good. Now all I have to do is do the inside. And I have a couple of options. I could put it where it's flush on this side, or I could put it a little more towards the outside if I wanted to. It's completely up to you and how you want to approach it. I'm going to put mine on the inside. I really don't need to worry about changing the settings on my fastener or my machine that actually does those settings for me. So all I'm going to do is just mark those and cut those. I'm set up for that over there, and that's what I'll do next. Okay, the next piece that we're going to be doing for our fastening systems for our sides is to create pocket holes. They'll be used as clamps along with glue, but it will also be used to keep these joints nice and tight while the glue dries. It's as easy as taking the piece, placing it in the pocket hole jig, clamping it down, and drilling a hole. Just like that, it's done that quickly. I reoriented the camera so I can give you a full view of our corner module after it's been assembled. I've gone through the process of connecting all the joinery with pocket screws. Of course, I have dominoes inside there, but I've also taken the time to actually create the relief holes or the handholds in all of the ribs. Now, this module is really wide. If I do a measurement across, it's 34 inches. If I measure from point to point, it's literally 67 3/4 inches. And that in and of itself presents problems and a challenge when we're trying to transport it. A lot of times you'll see one stacked on top of the other. Also at the same time, because of its distance and size, you don't see too often any of the terrain or built-ups on corner modules. There's literally just a corner, and it has your track radius on there. So we can adjust those a little bit today. Now, as it sits, this module itself is pretty light. It only weighs about 12 pounds. Once you put the sub-road bed on it, it's ready for track, and it's ready for any scenery that you want to put on it. Let's take a look at one of the possible alternatives though. If you're looking for an alternative to the large diamond corner that we saw earlier, you may consider this as an option. This is actually a geometric shape, and what it does, instead of being one piece, it's two pieces. What this allows you to do is allows you to still have the 24-inch module, as you see here, but the diamond is actually built into the end. So no longer is it 30 some odd inches wide, and no longer is it at 67, it's literally at 24 inches wide and 37. This allows it to be transported a little more easily, similar to the modules you currently have, or it can fit in one of our module cases. So when you put them together, that literally is your 45. And it has the exact same footprint, and if you put the other one on top of it, you'll see that it's identical. Now, there's a couple of things that you can do with this since it's a geometric shape. First of all, you can put one side around, connect it up in this pattern, and now I can have a kick out. Very easy to do. It takes no time at all, but I can also kick it out in that direction as well and create a module specific for that. That's also easy to do. This transport very easily, and all the same techniques are used to create the module like we saw with the riser. You can use the same techniques for the back, the front. But what this also gives you the option to do, because this is perfectly square along the front, I can actually put a module here, or even maybe make a cross piece to where you can change out scenery. Possibilities are endless. So this projects have been really fun to build. They don't take a whole lot of time as long as you prep and make sure that all of your angles are correct for both your blocks as well as the sides for your system. All the other techniques are identical. You can still use your techniques for risers as far as terrain and do the ribs. Everything still applies here. Now for next time, we're going to work on tunnels, and we're going to learn how to create culverts and incorporate those in your modules. So until then, we'll talk to you soon.